Hi everyone, my name is Tyler Bacorn and I welcome you to my presentation on MaintNorm, a corpus and benchmark model for lexical normalisation and masking of industrial maintenance text. I'm a PhD student at the University of Western Australia, and this work was done in collaboration with Melinda Hodgkins and Wei Lu. All three of us are researchers at the Australian Research Centre for Transforming Maintenance Through Data Science. So why do we want to build a corpus and model for lexical normalisation and masking of industrial maintenance text? To give you some context about what I mean by maintenance, it's essentially all actions to preserve or restore an asset's function. Assets can be any physical thing, such as pumps, haul trucks, building, aircraft, and so forth. With billions in annual investments, this process is critical for asset-intensive industries such as mining and resources, transportation, defense, and manufacturing. In these sectors, the failure of assets to function can lead to downtime that can be costly, impact safety, and breach regulatory requirements. As a result, experts working in this area, typically reliability engineers, use user-generated content in the form of work order records to gain insight into their assets' behavior, enabling them to develop strategies to avoid such downtime events. However, much of this information these experts work with is trapped in short-form content called maintenance short text, which look like what you can see here on the right of the screen. Some of the challenges that domain experts face from working with these texts is due to their low linguistic quality, composed of technical language, informal grammar, erroneous spelling, and non-standard casing. Furthermore, this short-form content includes confidential and commercial information, as well as sensitive details concerning proprietary systems, employee information, and asset identification information, among other things. As a result, there's a shortage of such datasets that are presently accessible or available to both researchers and practitioners due to organizations being hesitant to release this kind of textual data. Although there has been some research done on the normalization of maintenance short text in the past, it has been mostly limited to context-insensitive methods that rely on heuristics, rule-based approaches that use dictionaries, and distance-based approaches such as Levenshtein distance. Unfortunately, these context-insensitive methods are prone to errors and require manual rules for each unique context and organization that employs them. In contrast, contemporary methods used in the task of lexical normalization rely on supervised deep learning, on the supervised deep learning paradigm. Typically, they take form of a sequence-to-sequence learning task, where the current state of the art for multilingual lexical normalization uses a token-by-token autoregressive approach. However, because they rely on supervised deep learning methods, they require annotated datasets to learn the particular task. Currently, such datasets don't exist for maintenance short texts. So to overcome this gap, we constructed an annotated corpus. First, we collected 12,000 individual texts from 3 large mining organizations within Australia, each contributing 4,000 texts each. We used a tool called lexical, developed by our research group, to perform the annotation process according to the guidelines proposed by Hahn and Baldwin. We ensured that the lexical content was normalized and labeled entities at the token level to protect sensitive information before releasing it to the public. After the annotation process, we processed and obfuscated the data to ensure that it was suitable for this public release. During the annotation process, we came across a significant amount of annotated texts. It was discovered that 95% of the corpus needed some form of normalization. Furthermore, the distribution of different types of normalization operations and masking operations remained consistent across all 3 organizations that comprised our base corpus. On the right-hand side, you can see an example of the input-output pairs that comprise the MaintNorm corpus. In summary, this corpus section of our paper constitutes the first annotated corpus for this particular task, which involves maintenance short texts. As part of our research, we aim to explore how we can automatically improve the quality of these texts by using the annotated corpus that we had acquired. This would help practitioners enhance the quality of their analysis by simplifying the language used within their texts. To achieve this, we used a transformer-based encoder-decoder model under a sequence-to-sequence learning paradigm, similar to the state-of-the-art for lexical normalization. Our approach differs by involving mapping potentially noisy input sequences into a deterministic structure by marking up non-canonical spans of text with sentinel tokens and converting them into canonical forms on the right side of the structure, as you can see here in the figure. We borrowed this technique from autoregressive entity retrieval and chose it for 3 reasons. Firstly, directly transforming noisy to clean text can lead to issues in evaluation when there's a misalignment between input and output sequences. To our knowledge, aligning arbitrary sequences remains an unsolved task. Secondly, the token-by-token normalization approach using the state-of-the-art doesn't consider the entire context when performing normalization, as it's an individual token-based approach, and our intuition is that better results can be achieved by considering the entire sequence at once. And lastly, the fixed grammatical structure of our proposed technique enables the use of prefix-constrained decoding to control the output structure, therefore circumventing potential hallucinations. Moreover, this expressive output also allows us to encode semantic token-level labels with no modification to the model, only the training dataset. To test the effectiveness of our proposed approach, we used the MaintNorm corpus. We used the same baseline models for lexical normalization as outlined in the multilingual shared task, and selected the best performing model as our baseline, which was UFAL, the token-by-token normalization approach. We measured the performance of our models and the baselines using precision, recall, and error reduction rate, and conducted 3 different experimental setups. Firstly, we analyzed the performance of the individual companies and then combined the data to observe the industry-level performance of those organizations. Finally, we conducted combinational experiments where we provided varying amounts of training data to each company to reflect the benefit of some companies sharing data to benefit others that do not. Our work's result indicates that of the MaintNorm corpus, our proposed sequence-to-sequence modeling approach using an explicit normalization encoding scheme outperforms all the baselines by a significant margin. This approach demonstrates promising results for lexical normalization of industrial short text. The high scores attained suggest also a good level of success, making it practical for a particular adoption in this particular case in a practical setting. The main findings of this study indicate that our methodology for annotating maintenance short texts was effective in capturing relevant phenomena and is reproducible. Although almost the entire text required normalization, and with the main issues being casing, spelling errors, abbreviation expansion. These issues were consistent across all company splits for our particular maintenance context, with the most frequent mask or a token level tag relating to alphanumerical identifiers within each organizational dataset. Regarding our sequence-to-sequence modeling, we found that our encoding scheme outperformed all baselines, as evidenced by a high precision and significant error reduction rates when performing normalization and masking as a unified task. Additionally, our error experiments showed that extra training data improved the model's overall performance as expected. To summarize, our work has made important contributions to the field. First, we've created the first publicly available normalization corpus specifically for industrial maintenance short text. Secondly, we have proposed a sequence-to-sequence model that outperforms other models we've tested, setting a benchmark for future research in this area. We've also made our corpus, model, and code available on GitHub for others to access. Going forward, our plan is to enhance the robustness of our datasets by engaging more annotators and utilizing inter-annotator agreement metrics, as this annotated corpus was done by a single annotator. We also intend to investigate the use of our modeling approach for longer text corpus. And lastly, we aim to make the model more versatile and adaptable to a variety of industries and contexts, ultimately trying to improve its overall usefulness. Thank you very much for listening to this presentation, and if you have any questions, I'll be happy to take them. Thank you.